NOX was a first-generation Openflow controller. It is open source, stable, and widely used. There are two flavors of NOX: Classic NOX and the new NOX. Classic NOX was written in C++ and Python and is no longer supported. The new NOX is C++ only. The codebase is fast, clean, and well supported. More information about NOX is available at noxrepo.org. In a NOX network, there may be a set of switches and various network-attached servers. The controller maintains a network view, and the controller may also run several applications that operate on that network view. The basic abstraction that NOX supports is a switch control abstraction, where Openflow is the prevailing protocol. Control is defined at the granularity of flows, which are defined by a 10 tuple in the original Openflow specification. So depending on whether a particular packet matches a subset of values specified as a flow rule, the controller may make different decisions for packets that belong to different parts of flow space, or packets that match different subsets of the fields defined by a flow. A flow is defined by the header, or the 10 tuple, which I just alluded to, a counter, which maintains statistics, and actions that should be performed on packets that match this particular flow definition. Actions might include forwarding the packet, dropping it, or sending it to the controller. When a switch receives a packet, it updates its counters for counting packets that belong to that flow and applies the corresponding actions for that flow, which might include forwarding, dropping, or sending to a controller. The basic programmatic interface for the NOX controller is based on events. A controller knows how to process different types of events, such as a switch join or leave, a packet in or a packet received event should the switch redirect the packet to the controller, as well as various statistics. The controller also keeps track of a network view, which includes a view of the underlying network topology, and it also speaks a control protocol to the switches in the network. That control protocol effectively allows the controller to update the state in the network switches. The NOX controller implements the Openflow Protocol. NOX is implemented in C++, and it supports Openflow 1.0. A fork of NOX called CPQD supports versions 1.1, 1.2, and 1.3. The programming model is event-based, and a programmer can write an application by writing event handlers for the NOX controller. NOX provides good performance, but requires you to understand and be comfortable with the facilities and semantics of low-level Openflow commands. Later in this module, we will explore controllers based on pyretic and frenetic that do not have this characteristic. NOX also requires the programmer to write the control application in C++, which can be slow for development and debugging. To address the shortcomings that are associated with development in C++, POX was developed. POX is widely used, maintained, and supported. It's also easy to use and easy to read and write the control programs. Of course, as might come with implementing a controller in Python, the performance of POX is not as good as the performance of NOX.